Grade 10 Physics, Chapter Light, Reflection and Refraction, Module 6. Objectives. At the end of this module, you will be able to identify refraction, comprehend the cause of refraction, analyze the refraction through a glass slab, state the laws of refraction. We know that light travels in a straight line path. This is true as long as light rays are traveling in the same medium, having the same density throughout. If, however, the light rays are made to go from one medium to another, the light rays change their direction at the boundary between the two media. For example, when a ray of light traveling in air goes obliquely into another medium glass, it changes the direction on entering the glass block. The change in direction of ray of light occurs again when it goes out from glass into air. Refraction. The change in the direction of light when it passes from one medium to another obliquely is called refraction of light, or the bending of light when it goes from one medium to another is called refraction of light. The refraction of light takes place at the boundary between the two media. Here you can see a glass slab and the refraction of light through it. Cause of refraction. The refraction of light is due to the change in the speed of light on going from one medium to another. Greater the difference in speed of light in the two media, greater will be the amount of refraction of light. The speed of light is different in different media. For example, the speed of light in air is 3 into 10 raised to 8 meter per second, whereas that in glass is 2 into 10 raised to 8 meter per second. It is clear from these values that the speed of light is more in air but less in glass. Optically rarer medium and optically denser medium. A medium in which the speed of light is more is known as optically rarer medium. A medium in which the speed of light is less is known as optically denser medium. Glass is an optically denser medium than air and water. It has been found that when a ray of light goes from a rarer medium to a denser medium, it bends towards the normal. When a ray of light goes from a denser medium to a rarer medium, it bends away from the normal. The perpendicular distance between the original path of incident ray and emergent ray coming out of the glass slab is called lateral displacement of the emergent ray of light. Effects of refraction of light. The refraction of light produces many effects which can be easily observed in our day-to-day life. We will now describe some of the important effects of refraction of light. It is due to the refraction of light that a stick or pencil held obliquely and partly immersed in water appears to be bent at the water surface. An object placed under water appears to be raised. The stars appear to twinkle on a clear night. The lemon kept in water in glass tumbler appears to be bigger than its actual size when viewed from the sides. When a thick glass slab placed over some printed matter, the letters appear raised when viewed from the top. Laws of refraction. The refraction of light on going from one medium to another takes place according to two laws which are known as the laws of refraction of light. These are: according to the first law of refraction, the incident ray, the refracted ray and the normal at the point of incidence all lie in the same plane. The second law of refraction gives a relationship between the angle of incidence and angle of refraction. This relationship was discovered by Snell experimentally. So the second law is also known as Snell's law of refraction. According to Snell's law of refraction, the ratio of sine of angle of incidence to the sine of angle of refraction is constant for a given pair of media. That is, sine of angle of incidence by sine of angle of refraction, which is equal to constant, and the constant is called refractive index. Let's have a problem. Suppose for a ray of light, angle of incidence is equal to 37 degree and angle of refraction is equal to 24 degree. Find refractive index. By substituting the values in the formula of refractive index, we have sine 37 degree by sine 24 degree, which is equal to 0.6 by 0.4, which is given in the question. That is, refractive index is equal to 6 by 4 is equal to 1.5. Listen, refractive index has no units. In this module, you have learned about refraction of light, refraction of light through a glass slab, laws of refraction.